Hi, I'm Vincent and welcome to my channel Technomoira. I've been absent for a while and I'm going to bring you a little update on my situation so far. So sit back, relax and enjoy the episode of today, which will entail a little bit of housekeeping in my lab. A lot will depend on how well I do financially. And there you go. Vegetables spread on a pizza. Now we put the ham on top. Alright, so before I can do necessary maintenance on my soldering iron, I need to open it up, right? And for that I need a little screwdriver, a Phillips screwdriver like you see right here, okay? And yeah, and then I can open it up by taking out, for starters, this screw here. Now, most of my equipment, no, let's say half of my equipment is I would say, Chinese origin. Now, I know some of you will pull up their noses to that and say like, oh, Chinese equipment, not very good, and you know, yeah, some people will say that that isn't a good choice to make. I would say, you know, I'm a little bit strapped for money. I can't afford the, let's say, the top of top quality equipment because, well, I just don't have that much money, right? So I have to make do with equipment that is reasonably priced. Unfortunately for me, some of that kind of equipment does have a tendency to break down rather quickly, right? And therefore it needs a little bit more maintenance, which is a pity actually. I mean, basically the Chinese stuff is not bad. I mean, most of the Chinese equipment I have is not bad. In fact, some of it is rather smart. Yeah, I mean, like this little temperature regulated 80 watt soldering iron is really, I love this soldering iron. It's compact, it's light, and I can set the temperature to any level I want just with the twist of a little knob. But unfortunately for me, the heating element they put in it is, well, I would say on the weak side. Yeah. So if I use it constantly, and the element has a way of breaking down after a while. Okay, so you unscrew the top of the soldering iron, or I should say the tip, yeah, and then there is the element that we need to replace. Alright, I had said a minute ago that it's an 80 watt, but no, I'm wrong. It's a 60 watt heating element, alright, and the type is 907H, just in case you would be looking for the same kind of heating element. So my desoldering gun is hot and is ready, so let's unsolder let's unsolder the heating element and then replace it. Now, as I said before, I have practically no income from my channel, and the reason for that is quite simple. Years and years and years I refused to allow YouTube to make publicity on my channel because, in my opinion, I thought that, you know, people come to my channel not to enjoy, quote unquote, watching publicity, but to enjoy watching the content I make. Also, I was a bit uncomfortable with the idea that some company would be making publicity with the benefit of my channel as a spreading medium, but it would be publicity that I would not necessarily, for stuff that I would not necessarily endorse or that I would like even. So I felt thoroughly, let's say, annoyed by the fact that I had no say over which company would be showing which kind of publicity on my channel, and therefore I didn't allow YouTube to use my channel for publicitary reasons, which of course means that YouTube, the YouTube algorithm, of course, started to ignore my channel and would not suggest it to viewers, right? I think I need to clean the filter of my desoldering gun. So yeah, the YouTube algorithm wouldn't suggest my channel to other viewers because of that. Yeah. Now has come the moment that, you know, my channel has become a little bit too expensive for me to take care of, so to speak, on my own. I mean, something you people don't know yet is that I recently retired. I retired, in fact, the 1st of July this year. So I am officially retired. There you go. This is the resistor, okay? So a 907H, which means, of course, I quote unquote earn less. I mean, a retiree isn't paid as much as a working person, which is normal. I'm not complaining about that. But as is typical in life, you know, life always throws you a curveball when you least expect it. One of my parents, in fact my mother, who's an old lady by now, had an accident. She broke her shoulder, she broke her nose, so she had a really nasty fall, and I have to take care of her, and obviously not every day and not all day long, luckily. I mean, I still do get help, but yeah, it's it makes my life a lot more complicated. I mean, at least for now, I have less time to spend on my channel, unfortunately, which means that for a while at least you'll be seeing less videos on my channel. You'll be seeing less videos on my channel, and yeah, you will have to be a bit more patient. At at least until I find a way to to solve that practical problem, let's say. I mean, yeah. Obviously, my mother gets precedence over anything and everything else. So yeah, there you go. Enough ranting. So that's one of the reasons why I haven't shown up lately with new videos on my channel. Yeah, I'm sure you will understand my reasons for not showing up with new videos, at least for a while. Now, I decided that I would do this video as a sort of warming up exercise. I've been out of the loop for at least 3 months now. So, yeah, I hope you'll enjoy it. Alright, I soldered the last few wires to the print board. Okay, let me show you close up. Alright, so there you go. The wires are soldered up, and this is the back. Okay, so all I need to do now is cut away the excess wire that I don't need anymore. So, and I do this with a pair of flush cutters, right, like this. So there you go. Yeah, having a good pair of flush cutters is great in your lab. I mean, these are a little bit worn. They're not that sharp anymore, so I would need to buy a new pair. But anyway, which of course brings me back to my previous point, which is that I started my channel not to make a living of it, or not to do some profiteering with it. I just started it because I felt like sharing. I felt like sharing my passion, which is electronics, always has been my passion from a young age, with other people. So, yeah, I mean, it's interesting. There's a lot of math involved with it, you could say, although you don't actually need the math to do the hobby, yeah, but I mean, if you of course want to go into the rabbit hole and understand how everything works in electronics, you might have to use a little bit of math to do that, right? So anyway, long story short, I never earned anything, to be honest, with my channel, simply because I always refused to allow, how to say, to allow YouTube to make publicity on my channel. Yeah, I just didn't allow them to make publicity. But unfortunately, now that I'm a pensioner and with my mother that I need to take care of, and yeah, earning less as a pensioner, so to speak, I just don't have that much money anymore, you know. So I hope I will be able in the future to still bring some very interesting stuff to the channel, but a lot will depend on how well I do financially, right? So yeah, a few more subscribers and a little bit more watch time on my channel would be nice. So if you look at my if you watch my videos and you like what you see, then please do subscribe. Okay, so that would be doing me a big favor. Okay, so there you go. My soldering iron is repaired, I think. So let's just check with my other one. Yes, we're good. So now comes the proof of the pudding, like they say. So let me put it into the AC outlet and see if what I made is a soldering iron or a time bomb. Right? So here we go. Let's switch it on. Okay. The heating LED switched on. Feeling, yeah, I can feel the resistor heating up. Oh yeah. Oh yeah, yeah. Yes, perfect. I think this soldering iron is repaired. Years ago I managed to score this isolation transformer. I think it was on eBay. I don't remember exactly, but yeah, I think it was on eBay. And the isolation transformer came with an enclosure like this, which is a DIN approved plastic enclosure which protects the whole device, so to speak. Yeah, so it's hard plastic. It's transparent at the top and it has a seal at the bottom. So technically it's moisture proof. I wouldn't say it's waterproof, but it's moisture proof. Yeah, or water resistant, you could say. So which is a good thing. But of course I made a few modifications to it. So basically the transformer, which is this lump of metal here, okay, the transformer shares the home, you could say, yeah, or the housing with other equipment inside, yeah, which is a light bulb, a 150 watt light bulb, and the voltmeter and volts and amp meter you see here. Now with the switch I can switch it to either normal functioning, quote unquote, which is just a pass-through, to the output, which is here. It's fused, there's a fuse on it, okay, and the fuse is right here, okay. This is, I don't know if you guys can see this, let me show you close up, okay. So the fuse that goes to the output of my isolation transformer is right here, okay, and this light bulb here is a 150 watt halogen light bulb, which allows me to put it in circuit, yeah, with the output of my isolation transformer. And that way, if I connect equipment to the isolation transformer, of which I suspect there's a short, well, the light bulb will sort of slow down the current intake of the shorted equipment. Okay, so which means that the light bulb will actually start to shine very, very brightly when there's an actual short in the equipment, and only very slightly so if there is just normal current draw. Okay, so yeah, some of you might say, yeah, but why did you take only 150 watt? Why not 300 or 500 watt? Well, because this transformer here can only take a load up to, say, slightly less than 400 watts. Okay, and if I were to have to sacrifice anything, yeah, in a short situation, then obviously I would prefer to sacrifice a light bulb, yeah, or a fuse rather than the transformer. So yeah, I prefer the light bulb to take the brunt of the short rather than the transformer. Okay, so anyway, here is the meter. Okay, and yes, it's Chinese made. Yeah, and I need to find out what's wrong with it, and for that I need to disconnect it actually, which is what I'm going to do right now. Now, this meter has two, you could say, quote unquote, connections. Okay, one is the current wire, yeah, okay, which is this wire, which passes through the device here, yeah, and that's how it senses how much current I send out to the output of the isolation transformer. And then it has two wires at the bottom right here, which I need to disconnect, which are wires that supply it with the voltage to be measured, right? And that voltage actually also powers the display and everything. So I need to have a look at this to see what could be possibly wrong inside. Alright, so here it is. Okay. So this shows you exactly how it should be connected to the power, right? I hope you guys can see this. So there you go. So the wires that go to the load, which is this symbol right here, yeah, there's one wire that goes through the meter. Okay, so there's an opening right here, you see, and that's one of the wires that goes to the load, yeah, goes through this opening. Okay, and that's how it senses the power being drawn, well, I should say the current being drawn through it. Okay, and then you see two smaller wires down here which measure the voltage over the equipment. Okay, so yeah, that's how it is supposed to work. But like I told you, it just doesn't want to show the actual voltage anymore, or current for that matter. So I need to open it up. And to do that, there are two clips on either side of the housing. You see two here, yeah, and then you see two here. Okay, so let me see how I can open it up without breaking the thing. With two screwdrivers. So let's see. Let's see. Okay. Yep, there we go. Up. Okay. Let me show you close up. Okay. So there you go. I don't think the display board would have any problems, so to speak. So let me see. What could be the problem here? I don't see any obvious problems. But just in case, you know, I mean, I don't have any schematic of it. So just in case there could be something wrong with the capacitors, I'm going to replace the capacitors, which is, I believe, the best thing to do, the wisest thing to do with this, and then we'll see, we'll test it and see if that solves the problem, right? Okay, the last screw. Alright, there you go. I mean, I don't see any problems with the solder point. So what I am going to do is I'm going to measure those two power resistors, and I'm going to replace the caps with all of them with 50 volt rated ones, just to be on the safe side. Okay. Alright, before I can continue working on the volt and amp meter here, oh, by the way, I did measure the resistors, and they measure out correctly. I said before this is a 520 ohms, but no, of course I was wrong. Green, red, black is 52, and orange, black is 33, not 330. Okay, so 33 ohms. But they measure out correctly, so that seems to be okay. What I'm going to do, which is what in electronics parlance is called, is a shotgun the whole print board, in that I'm going to replace all of the electrolytic capacitors at once. Whether they are still good or not, I'm still going to replace all of them. So I listed all of them here. Okay, so there are two 4.7s, two 47s, two 10, and one 470 microfarad. Okay, only the 4.7s are rated at 50 volts. The others are not, so it's lower, 16 volt and 25 volts. Unfortunately, capacitors, which are electrolytic capacitors, which are rated, or capacitors in general, which are rated for a higher voltage, are, generally speaking, slightly larger than the lower voltage rated ones. Which I would say, some of you would say, which is logical, but in this case might give me a little bit of trouble making them fit on the print board. But still, I'm going to replace all of them with 50 volt rated ones, just in case. Okay, so my desoldering gun is not sucking solder properly anymore. So which means the filter, which is inside the barrel here, is full of old solder. So I need to replace it with a fresh filter like this, which is felt really, which is cut to fit right inside the tube you see here. So I need to pull this down, then this opens the barrel, and then I carefully pull out the tube, and I say carefully because I don't want to spread dirt all over my bench. So there I go, and then I release the filter. Oh yes, it was badly clogged with solder. Okay, see, you see here, you see that big blob of solder on top of it, yeah. So it's so badly clogged up that the spring which holds the filter to the end of the tube is actually stuck to it. So give me a moment to release the spring, and then I'll show you how to insert the new filter. Alright, so I reinserted the spring into the tube. So now I take the fresh felt filter, place it on top like this, and keep it inside the tube with my finger. Then you have the desoldering gun end right here at my pinky finger. There's the inlet, you could say, of the molten lead it sucks, right? And this tube here has an opening which fits, you see it here? Yeah, this opening fits right over the little inlet tube right there. So I place it like this over the inlet, and then I gently there you go. See the filter at the end of the tube right here? Alright, I finished replacing all the capacitors on the main board with new capacitors, and all the ones that I replaced I marked with a green marker on top, okay, as opposed to the ones I wouldn't have replaced, which would have still be blank. I replaced all the original electrolytic capacitors with 50 volt rated ones. I suspect that may solve the problem. Now, to come back on a previous remark I made, that these Chinese products are per definition not bad. In fact, some of them are pretty smart the way they are built, yeah. But unfortunately, Chinese producers often try to cut corners where they can to save a penny here, a penny there. And the best example I can give about their unfortunate tendency to cut corners is like using wires which are way too thin and too weak, yeah. And so the display let loose, yeah, because I was handling the whole device, taking it out, taking it back in, watching every angle of it to see if I didn't miss anything. And the little wires, which are 7 wires, which go to the display of the device, just broke off. I mean, all except one perhaps. simply by bending them, let's say maybe 5 or 6 times, yeah, they just broke. Now, okay, some of you might argue, yeah, but you know, once it's mounted inside the enclosure, the wires will never get bent ever again. True. I mean, technically speaking, they probably wouldn't have broken inside their enclosure. But even so, I mean, the device was obviously built not to be repaired or maintained again, ever. Spoiler alert, most of the electrolytics, except perhaps 1 or 2, were pretty leaky. I mean, like electrically leaky. So, yeah, I suspect the problem was truly with the electrolytics. Alright, I stripped the wires ready for soldering, and now I'm going to connect them to the main board. And there you go, perfectly soldered to the main board. Alright. You don't need to go overboard with solder, as long as the wires make a perfect good connection on both sides, because this is a double-sided PCB. You're done. Alright, I connected the volt and amp meter up to the AC with crocodile clamps or crocodile leads. You see there at the back. The fact that the leads are red and black really doesn't matter. It's irrelevant. It's connected to AC. Okay, so the moment I throw the main switch on the power outlet, it should display some voltage around, let's say, anywhere between 220 and 240 volts AC. Okay, and it should stay on, permanently on, so not blink the way it did before I refurbished it, right? So, okay, let's throw the switch and see if it goes boom. Here we go. Okay, that's bizarre. So it's still blinking. Alright, so I finally managed to repair the volt and current meter. And it turns out that the problem was not so much the electrolytics, which all of them I replaced. Neither was it any of the resistors on the PCB, but it turned out to be the combination of bridge rectifier and separation capacitor on the print board. So there is no transformer to provide power for the whole circuit. It's rather capacitively coupled to the AC. Okay, and from this heavy capacitor, yeah, the AC power goes immediately to a bridge rectifier. And in fact, the original capacitor and bridge rectifier are here. So I don't know if you guys can see this, but the parts, especially the original bridge rectifier, is really small. So there. So this is the original bridge rectifier, that little part right there. Okay. And this is the isolation capacitor, or you know, that was installed originally on the power supply side. This one is rated for 120 nanofarad 450 volts. This little bridge rectifier was rated for 1000 volts reverse peak voltage and half an amp. I replaced both components with a brand new bridge rectifier which can withstand 1000 volts peak reverse voltage and can deliver up to 1 amp. And the capacitor that I installed instead of the original one is a 220 nanofarad rated at 630 volts. And in my opinion, that as it is now, it should last forever. My previous remark is still valid. I mean, the Chinese make rather nifty things that you often can't find on the market, right? And they are quite good at miniaturization of equipment and all that. But quite often they cut corners to save a few cents left and right, you know, to make a little bit more profit. And often that leads to equipment which unfortunately doesn't always last as long or can withstand as much punishment as let's say more solidly built equipment. Unfortunate, but I mean, we've seen this kind of evolution many years ago in equipment built abroad, you know, like in Malaysia, in Japan, in India, and steadily the quality of the equipment over the years has improved. And I think we will see the same kind of evolution with Chinese equipment. So there you go. Unfortunate that I didn't have the schematic of the meter. That would have saved me quite a bit of time. But that being said, it's okay. I mean, I discovered a few things, I learned a few things, and it was interesting nonetheless to look for the fault in the device. So now all I need to do is mount it back in its case and then mount it back in the isolation transformer case, which is over there. There you go. That's the resume of what in effect I replaced on the volt and current meter. Okay, so these are all the electrolytic capacitors that I replaced. Let's see, 7 in total. The original bridge rectifier, which was of the type MB10S, I replaced with a bridge rectifier of a type DB107. Basically, this is the dip version of this one. Except that this one can take up to 1 amp in current at 1000 volts peak reverse voltage, whereas the original bridge rectifier can only deliver up to half an amp at 1000 volt peak reverse voltage. Also, I replaced the isolation capacitor, which was plus minus 120 nanofarad rated for 450 volts, by a capacitor, a Mylar capacitor of 220 nanofarad rated at 650 volts. And that fixed it. So there you go. And I mounted everything back into its case. So the display and the print board. There you go. Okay. 3 screws for the print board, 4 for the display at the back, and that's it. For those of you who are interested in what type of isolation transformer I use, here are the specifications. And there you are, reunited and placed back in their rightful place. Lastly, I'm going to repair my trusted microwave oven. I've had it for a number of years, I think 15 years at least, and it has always served me faithfully until recently. The light bulb, which lights up the interior while it's cooking something, gave out, and there's no way of replacing the light bulb from the inside. I had a look inside, and there's only a little cover up here, yeah, and this covers up the klystron, but there's no way I can reach the light bulb from in there. I tried, and well, it's impossible. So what I'll need to do is open up the case of my microwave oven and then replace the light bulb from the side, from there. Alright, I unscrewed all the screws, so now I should be able to remove the case. And indeed it comes off. There you go. And now we can have a look inside. Alright, so this is the business end of my microwave oven, and there's quite a bit of stuff packed in here. Now, the 2 things that, or maybe 3 things that should be obvious to any of you is 1, this part here, which is called a klystron. This is in fact the tube, because it is a vacuum tube, which radiates the microwaves that cook your meal, right? And it's called a klystron, and obviously this is a very dangerous thing, so you should never ever be exposed to its radiation, right? It radiates somewhere, I would think, in the 2.4 gigahertz range. Okay, and it's really unhealthy. So that's why the microwave is surrounded by a metal case, right? Like a Faraday cage, you could say. Now, the other thing that should be obvious inside here is the transformer. Yeah, this produces the necessary high voltage to run the whole machine, and also the klystron above it, right? And when I say high voltage, I mean voltages upward of 2000 volts. Okay, so my advice is, if you have never worked on an electrical appliance like this before, yeah, don't do it yourselves unless you know perfectly well what you need to do, okay? Because if you follow me as I'm going along, you do so at your own risk. I'm not joking. The voltages inside of this appliance are lethal, okay? So anyway, what else can I see? A fuse right here, and then the capacitor, the filter capacitor for the power supply of the klystron, which is located down there. Okay, again, don't touch the poles of the capacitor. It could still be charged, and although it might not kill you when the machine is off, it can certainly hurt you. Alright, I am on the DC range of my multimeter, and it measures 400 microvolts. Okay, so less than 1 millivolt. So for all intents or purposes, the electrolytic, well, no, the capacitor is empty. There's no electrical power stored in it, so I'm safe. Alright, so the next part that is obvious inside of here is what I think is the power supply right here. Okay, and there are a few fuses inside here. There's one here in that holder down there, and there's one over here. But since the machine basically works, I don't need to do anything to that. And then there's the front panel PCB, which is over here, and that you see at the back right there, that's where the display is and the buttons are. Okay, and that whole front PCB is connected via wiring, via a flat cable you see over there at the back, yeah, to this board here, which contains all the wiring to well, make the machine work, right? So all the relays and etc. And switches are located right here, and then that, as I said, is the power supply. Okay, and then to end it all, this is obviously the fan which circulates the air around in the microwave, and this one runs, if I'm not mistaken, on 220 volts. It's a brushless fan, okay, so, or motor I should say. Right, but you know, the goal of this all was to replace the light bulb, and in fact the light bulb of my microwave oven is located right here at the top, right here. So all I need to do is to unscrew the socket with this one screw, and then we can have a look at the light bulb. And now we can lift the whole thing out of the enclosure. Come on. There you go. And here is the light bulb. Yeah, you can tell the light bulb blew out. And I mean, after about 15 years of faithful service, I guess it thought it was its time to give up the ghost. So the replacement for the original light bulb of my microwave oven is this one here, and I propose to replace it by this. This is one of those filament LED light bulbs, yeah, which are really basically very simple of build, and they, if I'm not mistaken, they are rated for 1 watt power, okay, which I think this one is rated for, at least if it's marked on the light bulb, and it isn't, not that I can tell. I mean, maybe you guys can see it, but I can't. Let's see, 220 volts. I can just about see 220 volts, and then something watt, but I can't read it, it's too small. So anyway, I think this can't be much more than maybe 2 or 3 watts, right? So I think actually it's rated like for 4 watts maybe. So it doesn't matter. I don't need to have it illuminated super brightly. I just need a little bit of light to tell me whether what we're cooking inside is ready to eat or not. And I think this LED light bulb should do nicely. Alright, so I installed the light bulb in the socket. By the way, the socket is completely made out of plastic. Okay, so there you go, that's the LED light bulb. So now let's see if it'll run without breaking. Alright, let's make some pizza. Vegetable diced, now we put it on the pizza. A dash of black pepper on top. And now we finish off with the cheese. First some Gruyere cheese, grated. And then we finish off with a little bit of Parmesan cheese. There you go. And now we shove it into the microwave and we wait. Whoops, that's piping hot. And there you go. One piping hot pizza ready to eat. Bon appetit and thanks for watching.